guys, here we've got a Goodman package heat pump, and the complaint is that the unit always runs in heat mode whether or not we have it actually set in heat or set to cool. Either way, we got warm air coming out of the vents. This is a package heat pump. I'm not responsible for that taping job, by the way. What I've done here is set the unit to operate in cool mode at the thermostat, and I want to come out since it's running in heat mode and check to see if we've got 24 volts on the low voltage circuit for the reversing valve, telling it to actually operate in cool mode. This will eliminate the thermostat as a possible problem. So this bright sunshine may make it difficult to see, but right here we've got our low voltage pigtails that come directly from the thermostat. So this being a Goodman unit, we know that the reversing valve is energized in cool mode, which is going to be on this orange circuit. What we want to do to see if it's getting a command to operate in cool mode, to ensure that it's energized. Well, look, we've got our common taped up. We want to check this orange wire to a low voltage common in the thermostat and see if we are getting a 24 volt signal. So we're going to place one lead here, find a common, which I'm going to use the side of the contactor here for, and measure. And it appears we have no low voltage signal. So double check that. I basically, look, this is an old school way of doing it, but this is the way I do it in the field. You just got to be really careful handling live power, even though it's 24 volts. So I'm going to jump these out, red to orange. And when I do that, I don't know if you can tell on the video or not, but the reversing valve shifted. The unit is operating in cool mode. So what I'm going to do is back up and check out the thermostat to see if the programming is set up right or we have got a faulty thermostat. Okay guys, so we're back inside with the thermostat, and at this point we pretty much have two possibilities. One of those being the thermostat itself, which is probably the most likely culprit here, or we have a bad wire for the reversing valve between the thermostat and the unit. And you know, there are many different ways that you can go about checking this. Just through experience, this is my own method for determining which one is the problem. What I'm going to do is I'm going to just pop off the thermostat and expose the control wiring. So what we're trying to do is we're trying to verify whether or not it's possible for the thermostat to send 24 volts to the unit. So what I'm going to do is bypass the thermostat, and the easiest way to do that is just simply remove orange from the OB circuit. Remove R from the R circuit. You can do this with a wire nut, pair of pliers. Sometimes with certain thermostats you can actually screw these together. But I'm going to basically just ensure that the copper conductor for the orange wire and the red wire are touching, like so. So with the unit power on, this wire, the red here, should have 24 volts AC power on it at all times. So we're basically just forcing the R circuit to the O circuit and seeing, now I'm going to go back out to the unit and see if we've got a 24 volt signal on our orange wire. So if we do, at that point we know that this orange conductor is okay and that the problem lies within the thermostat. If we still don't have 24 volts with these two wires basically jumped out, then we'll know that we have a problem with the orange wire. If the orange wire winds up being the case, then we've got spare conductors in here that we can test out and see if they're broken or not. Alright, so after I took outside of the unit, I measured between the same orange conductor that I did before and common off the contactor, and we do have 24 volts with these two wires jumped out. So at this point we know that the conductor going from here to the unit outside is okay, and that the problem lies within the thermostat. So depending on the thermostat, you've got multiple options here. This being a Nest Wi-Fi thermostat, there are program settings that I can go through to check and see if maybe for some reason the programming has gotten reset. If that's not the problem, if the program is still set correctly but the thermostat's not sending 24 volts, then the thermostat itself is faulty and we will replace at that point. So I'm going to wire everything back up and go through that. So all these thermostats are, have proprietary software. They all operate a little bit differently than others do. Gotta make sure I've got that popped on correctly. Okay, once more. From the home menu, we're gonna highlight settings. We're gonna press the thermostat in. It's gonna take us to a settings menu. We've got all different kinds of options for programming, language, app, network, lock, equipment. So we're going to go to the equipment settings and see what is hooked up. And we do have, if you can't read that, it asks, does your heat pump use an O wire or B wire? And O is highlighted in check mark, so we do have the thermostat in the correct setting. So at this point, if we go outside and measure that indeed the thermostat, or the unit rather, is still operating in heat mode, we'll know we have a faulty thermostat. So after going back out to the unit for the last time, looks like we still do not have 24 volts present at the orange pigtail. So definitely the thermostat is the issue. At this point, we'll call our customer, explain to them what's going on with the system and find out what they want to do moving forward. So I'm going to go ahead and do that. Hey, Mr. Hood. Hey, Andy here. So, alright guys, so we're going to swap out a thermostat here. Taking out a Nest thermostat that had failed and actually swapping it with the good old tried and true Honeywell 3000. So it is kind of a step back in technology, but a very, very good quality thermostat here for your simple, single stage heat pumps. So first step in this process is always turn the power off. A lot of times we get calls from homeowners, I replaced my thermostat, now the unit won't do anything. Typically it's just due to that step. They forget to turn power off, and then when they start unwiring, they let hot arc to something, blows a fuse, shoots a transformer, etc., and then causes a total loss of cooling. So the first step would be to turn off power, and then once you do that, take the front off, and then you are going to unwire the hookup while noting their wiring layout. The wires don't know what color they are, so depending on who's here first, who knows how the thing was wired. So you want to make sure that the orange wire is going to the O terminal instead of them using orange for W or Y or whatever. So always take a good, quick note of that. Nothing wrong with using your cell phone camera to help you with this. I do this often when unwiring something, just to make sure that I get it back in the right place. So we've got the thermostat on the wall, and in the 3000, there's not really any programming. These are pretty much, you buy these as heat pump models or single stage heat models. So we're going to go ahead and switch this thing into cool mode and verify that the unit operates in air conditioning mode, and if it does, at this point we're done with the call.